Hello and welcome to the InfoQ podcast. My name is Wes Rice and I'm the chair of the International Software Conference's QCon. Today's podcast came about because of one of the interviews I do with speakers just ahead of QCon. Today we're speaking with Greg Murphy. Greg is the COO of Gamesparks. He was previously their chief architect. As I was doing an interview with Greg, I became fascinated with some of their approaches to providing a rich mobile backend as a service and platform for game developers to engage with their users or developers that are leveraging their services. So I invited him on the show to talk a bit about it. Today we'll do a deep dive into what GameSpark does. Greg will explain their architecture, including some interesting bits like the hosted server-side code their API developers can write themselves. He'll talk about managing their deployable units across Azure, GCP, and AWS, and even explore some of the experience moving into the AWS Beijing region and how they deployed into mainland China. It's an interesting chat. I hope you enjoy it. Greg, welcome to the InfoQ podcast.
Thank you. Good to be here.
You know, when I prepped for this, I guess probably naively, the way that I would describe GameSpark is just as a mobile backend as a service. But you're really more than that, right? What's the problem space that GameSpark solves for game developers?
I think when we first started on this journey building the platform, we certainly saw ourselves as another backend provider as well. But actually, since we've developed over time, we've realized that we can offer much more than that. And the better description we probably give for what we provide now is that we're an engagement engine, because really what's important for game developers is to be able to keep their players engaged in their games, keep them playing and be able to, in the end, monetize them. If players don't remain in games, then actually a game can't continue to be successful. So the power that we offer is the ability for developers to get started quickly and have all the benefits of a normal mobile backend, where they've got all this out-of-the-box functionality and they don't need to build their backends themselves. They can get moving quickly and get their games out the door. But once the game is live, because we have all this behavioral data about how players are interacting with the game, and at the same time we're able to control games from the server side, we suddenly have this ability to tune games in life and press all of those behavior and social science buttons with players to keep them engaged and keep their experiences to be as good as possible.
Wow, that's really interesting. So let's focus on that engagement engine. What are some of the things that you can offer as a provider that can help people stay engaged with a game?
One of the ways that we think is really powerful is to use game analytics and real data about how players are behaving to be able to tune a game. So the ideal type of game that uses GameSparks is one that's really server authoritative. So an example of that would be, say, a level-based game. The client can become relatively dumb in this respect. And at the beginning of the level, the client may check in with the server and say, hey, what are the parameters of this level? How should it perform for this player? So the server could reply and say the level should have this level of difficulty, it should have this many enemies in it, it should take this long to complete, etc. So where that becomes powerful is if from analytics a developer has seen that 50% of players are dropping out on this level, then the level is tuned to give different levels of different difficulty parameters to be able to encourage players to continue to play. Because once a player's gone, it's really difficult to get them back. It's much better to try and tune the experience while the player is still there and be able to keep them playing the game.
But what does that mean to tune the experience? I mean, is this, are you talking about scripting that developers can do that trigger events? Are you talking about machine learning that is developing kind of projections on what might happen? What does this look like?
Yeah, a bit of everything. Yeah. So if we talk about the functionality that GameSparks has, so out of the box, we have an API that presents around 180 different calls, covering anything from authentication with social platforms to doing things like multiplayer and virtual economies and challenges, teams, things like that. So if a developer walks along, they can get all of that functionality with just configuration. They don't need to write any code. Then on top of that, developers can extend any of that functionality with their own server-side JavaScript if they choose to, or then they can go and write their own custom APIs, again with server-side JavaScript behind them and also custom data stores. So by using any of those calls, their server-side logic can determine what the experience is for players. The next level on from that is to be able to apply machine learning to those behaviors, to identify trends within player behavior, to be able to then segment players and give them different experiences, or identify whether players are exhibiting anomaly type behavior. And the obvious example of that is cheaters.
Yeah.
So if we see that somebody is presenting a score that's way above what should be possible or is massively outside of normal bounds, then that player can be quickly identified and okay, their experience maybe becomes a bad one, because you don't want those guys being retained in the game.
Yeah. Wow. So a bunch of questions come out of that. I heard server-side logic. I heard, algorithms to detect cheating. So there's a bunch of questions I have there, but I guess we should back up for a second before we dive into some of those questions. What's the architecture look like? So most of us are probably familiar with a mobile backend as a service, at least. What does it look like after the point where I integrate an SDK to my app? What's the kind of big puzzle pieces that you're dealing with?
Yeah, so we present a couple of different interfaces into the platform for both our customers and game players. So the starting point is our management services. So they're our interface to our customers themselves, the game developers and game studios. So those services take the form of a web portal and a management API. We've actually just this week released a new version of our management services, and it's quite architecturally interesting because we've gone for an API first approach, meaning our portal is now a consumer of our management API. Previously, the two things sat side by side, so we had the usual issue of having to keep the two things in sync with each other.
So the same API that developers use is the same as the portal?
Yes, the developer portal is a consumer of the management API. So what that means is if a customer wants to go and integrate GameSparks with their own CI or any of their own internal workflows, they can do that with the confidence that all of the functionality that's available through the UI is also available through the API as well. So yeah, that's pretty cool. Our customers have been asking for that for a while, so we're very pleased to have got it delivered.
Okay, so that's on the management side, but what about on the game side where the game clients connect?
So the management services are, as I said, what we would kind of call our B2B interface. Then our runtime services are the endpoints that our game clients actually connect to. So whether you're running a game on a mobile or a PC or a console or any other device, they connect into our runtime services. So our runtime services are connected to via our SDKs, and we have SDKs for a number of different platforms.
I'm assuming you support a variety of SDKs, but what are some of the more popular ones?
Our most popular ones are the well-known game engines, principally Unity and the Unreal Engine. We're actually working on Lumberyard and CryEngine as we speak, and we should have that out the door fairly soon. We then have more specific SDKs for things like iOS and Android, or if we want to go even lower level, down to C++ or C#. We also have ActionScript SDKs and Cocos ones, Marmalade, Corona. There's a relatively long list that can be seen on our documentation site. Yeah. So developers install that SDK within their game environment. Obviously, some of the experiences are smoother than others. So with our Unity SDK, that's just a package that's installed into Unity, which gives the developer a GameSparks drop-down menu within the IDE.
Nice.
Whereas if you're working within C++, it's obviously a much lower level experience, as you'd imagine. So the game clients, as I mentioned, connect into our runtime services via our SDK. And these runtime services present the API that I mentioned earlier, and also act as the cloud code execution engine and also the data stores for the games. So when a game client connects into these runtime services, they've got access to this full set of functionality. The runtime services are the things that we have to massively scale, because when we talk about numbers at the moment, we have around 35 million monthly active players across our game. Last month we handled 15 billion API calls. So these are the areas where there's the real kind of architectural smarts and scaling smarts of the platform. The other services that sit alongside our runtime services are real-time services. So what they offer is real-time multiplayer gaming. Now, our standard runtime API is JSON over WebSockets, which is a relatively efficient mechanism for communication. But you can imagine if you're playing a real-time game where you've got to transfer data rapidly between all the players in that session, then that's just not fast enough.
Right.
So our real-time services offer an interface which is basically it's a custom protocol that we've written, but it uses protocol buffers over UDP, falling back to TCP if UDP is available, to do this very fast data transfer between players. Some of the some of the interesting things about the real-time services are the fact that we can also apply smarts to those packets that are being transferred between players.
Interesting. So it's kind of like a message router or something? Help me understand that.
So a way to describe that better is, if you think of the real-time service in isolation, then it's almost just like a packet proxy. It's rapidly transferring these pieces of information between players. But what you maybe want to do is take some server-side action on that data as it passes through.
Yeah.
So giving a specific example, we have some racing games that use that service, and what they're transferring between players is just simple pieces of information saying, this car is in this position, it's going at this speed, and it's got this angle of drift.
Sure.
And that's fine. That information needs to be able to get transferred rapidly between all those players. But actually what developers want to do is be able to then say, okay, I want to know when the first person has crossed the finish line, or the first person has gone past this point in the track, or actually if somebody's finished a level and they finished it quicker than is humanly possible, so we want to know they've cheated. So our developers are able to write server-side callbacks in JavaScript that act on these packets as they pass through and make server-side decisions about how to process that data. So it could be awarding an achievement to a player, or it could be marking them as a cheater or something like that.
Wow. Let's talk about that for a second. So server-side script, when you say our developers are able to write server-side scripts, is that your API developers or your own internal developers that are using it?
It's our API developers.
Wow.
Kind of a fundamental extension mechanism of the platform, because what we understand is, or one of our key principles in how we build the platform is, we try not to make developers' decisions for them. We think we provide a toolbox of services rather than a prescriptive service to our developers. So, what we know is no two developers' requirements are the same. There's some core functionality that any developer would want from a platform like this, the kind of things that we've talked about, like social integrations and multiplayer and virtual economies and the like.
Let's talk about that for a second. So say we're using, protobuf over UDP. We're transferring some location data or something along those lines. I can write a script then that is in JavaScript that I can run on your servers that will be managed by your infrastructure that can inspect that protobuf that's coming through there and be able to do work, act on it?
That's absolutely right, yes.
Wow, that's awesome. So, okay, a lot of questions there. So what about like noisy neighbors? What about security? What about all those things? How's all that managed?
Yeah, so we take all those things pretty seriously because we're by default a multi-tenant environment, so we need to be able to address all of those concerns. So from a security point of view, when each request is handled, so I should mention that all of our server-side code is written in Java. So when any request is handled, every request is managed within a Java security manager, which is given proxy objects to any of the data stores that it needs to be able to interact with. And each customer has its own data store.
Gotcha.
There's no possibility of that request being able to step outside of those boundaries and get to any other customer's data.
Right.
So then from a noisy neighbor point of view, we implement throttling on the platform. So if a script has consumed more resources than it should do, we'll cut it off. And we do that by injecting callbacks into the script at compilation time. So we don't wait for the script to end to decide whether it's been consumed too many resources. We're constantly getting callbacks during its execution. And if we see that too many resources have been consumed, we can terminate it.
When you say inject callbacks into the script, what does that mean?
So obviously the script is presented to us in an uncompiled state when a developer writes it. When we compile that, we inject our own callbacks into there. So during execution,
okay,
we get that data.
Gotcha. All right, so let's talk about. You mentioned Unity as being one of your more popular platforms. What does the developer experience look like with integrating into your app? And say, let's give it a specific use case. Say that we're developing a server authoritative app that you described earlier. What does it look like? I install something into my Unity package. I get these APIs available. What does that look like?
Yeah, so when you install the Gamesparks SDK package into Unity, you get a drop-down within the Unity IDE, which enables you to just put in a couple of basic pieces of information. So saying what your Gamesparks API key and secret are, plus the endpoint that you want to connect to. Now, the point about that is we have a developer sandbox for developers to test any of their games against and perform their development against. And then there's a live endpoint that their real players connect to. Functionally, there's no difference between the two. The only difference being real players only connect to one endpoint, and there's no cross-pollination of data between development and live. Once the developers set up Unity like that, they then have access to all the Gamesparks API calls natively within Unity, and they can choose to either call one of the... So yeah, let's talk through what a normal sort of journey would be in terms of a game.
Yeah, please.
So to start off with, the normal thing that would happen once the Gamesparks SDK has started up, you would authenticate the player in some way.
Right.
Against Gamesparks. There are multiple ways of doing this because identity is a complicated thing. In many cases, players don't want to be identified within the game. They don't want to have to log in through Facebook or some other mechanism. They just want to be anonymous. That's fine. We completely support that. We take an identifier from the device which is provided by the SDK. So we can identify that this device is the same one that's come back subsequent times. So simply that creates a player within the Gamesparks ecosystem, and then everything done by that device in the future happens within the context of that player. What's quite nice is if then subsequently the player chooses to authenticate by one of our third-party mechanisms, so whether that's Facebook or Xbox Live or PlayStation Network or Twitter, Google+, etc.,
yeah.
that identity is then tied to the same record. So whether the player is performing anonymously or whether they've logged in socially, if they're on the same device, we still know they're the same person.
All right, so you described this architecture. How is it served? I'm assuming this is all a cloud provider of some kind, right?
Yes, absolutely. All of our services run on public cloud providers, and we made a conscious decision relatively early on in our life to be able to deploy these services across as many providers as possible. And when I say as many providers, I'm talking AWS, Microsoft Azure, and Google Cloud Platform. Simply, they're the big three.
Interesting. So you deploy equally across AWS, Azure, and GCP?
Now, there are a couple of reasons for us doing this. And to be specific, the services that we deploy on these providers are our runtime services, the things that game clients connect into. The reason that we did this is twofold. On one hand, we wanted the largest or the greatest geographical reach that we could. So all of the cloud providers have different presences in different areas. So, for example, we have one of our runtime clusters deployed in mainland China. Google wouldn't be an option in mainland China for the reasons we kind of all know about. So that rules them out there. But on the other hand, we're working with a customer in a certain part of the world at the moment where Google are the only cloud provider that has a deployment, so they're the obvious choice for that location. At the same time, we have commercial reasons for deploying across the three clouds as well, because we have close partnerships with all of the three providers, and they bring us customer opportunities. They see customers who want services like ours. So the quid pro quo of them bringing the customer to us is we make sure we deploy that customer on their particular infrastructure.
What does it look like? I mean, when you deploy across these multiple environments, is this all one logical unit that's talking? Are these broke up into clusters, into sections? What does it look like when you say you deploy across all three providers?
Yeah, that's exactly it. The way we've designed our runtime services is we have a deployable unit that we call the runtime cluster.
Okay.
So the runtime cluster is by default multi-tenant, but it can host one-to-many games. So we have a commercial model where customers can choose to be single tenant with us, and they get one of these deployable units entirely for themselves.
Okay.
So the deployable unit consists of our API and server-side code execution engine. We call that server-side code cloud code, plus the data stores that sit behind those engines. So the data stores at the moment are MongoDB and Redis. We may well add other data stores into the mix in the future. The reason we chose those two to begin with is because all our server-side code is JavaScript. MongoDB is an obvious fit with its native JSON storage format. And then Redis is great for operating with sets of data or incrementing counters or things like that. So we expose both those data stores through our API for our customers to be able to use directly within their server-side code.
So when you say you expose that directly for developers to be able to use in their server-side code, what does that experience look like? I remember Parse that I used to be able to, create kind of any type of table essentially that I could then consume very easily with the API. I think Firebase uses like a JSON format that you can then interrogate and ask. What does that experience look like for GameSpark?
Yeah, it's a very, very similar experience. So through Cloud Code, developers can choose to interact with any of their own custom collections. So exactly as you describe it with Parse, you've got the ability to have whatever number and whatever format of custom collections that you choose to. So developers can insert, update, delete, query, any of the normal CRUD operations against these collections. And similarly with Redis, they can create their own custom keys and perform any of the normal Redis operations against them.
Nice. Okay. Running on GCP, AWS, and Azure. So when you talk about these clusters, they can be deployed across all three of that. How do you pull that off? I mean, is this a suite of containers that are deployed, sets of AMIs? How is that orchestrated?
Yeah, it's a little bit of both. So we're on the journey to containers at the moment. So some of our services we have built as containerized from the ground upwards. So our real-time services are a good example of that. Whereas most of our traditional runtime clusters are still just built in VMs. So we take a couple of approaches to be able to abstract the underlying cloud provider from the equation. So on one hand, we use a project called Packer to go and build our images. So Packer's great because it's all entirely manifest driven, and we can say we want our OS images to look like this, and then it will go off and build them on all of the respective clouds. And then on top of that, we use Puppet to go and configure the VMs when they're deployed. In terms of actually performing the deployment itself, we've built our own abstraction layer above the three cloud providers' APIs. So when we want to go and deploy any services, whether it's VMs for our API or for any of our data stores or absolutely anything within the platform, we just send a message to our deployment manager to say, go and deploy me this VM. And then that handles all of the underlying plumbing with the respective cloud provider APIs. So it's all about separation of concerns. All of the services, all of the requesters to get these VMs don't need to care about where they're being deployed to. That's all handled by the manager layer, which goes off and integrates with the APIs.
Is that manager layer something that you all developed, or is that an open source toolkit that you're using?
Yeah, no, it's all been in-house. Something that we may open source in time, but we may need to tidy it up a bit before we do that.
Yeah, I bet. What about elasticity? So how do you manage elasticity with these deployment clusters that you're using?
Yeah, so what we've explicitly done, and this raises a few eyebrows with people, is we've written our own autoscaler. There's a couple of reasons for that. We decided not to use the individual cloud providers' autoscalers because we wanted a consistent experience across all of the three clouds. Okay. And the only way we could do that is by writing it ourselves. So based on a number of metrics, so we capture in the tens of thousands of metrics every minute about the platform and how it's operating, whether it's anything from infrastructure level to application level to individual game performance metrics. And then based on those numbers, we make our auto-scaling decisions. So it might not just be because we're getting starved of CPU. CPU might be okay, but we might have hit certain other limits, like we've got the maximum number of connections we're comfortable with, or that we're getting towards heap exhaustion on a box or something like that. So all of those numbers feed into this algorithm, which decides whether we're going to scale both up or down.
Thing I wanted to focus on earlier, you mentioned something like 15 billion calls last month, and I asked you about whether you're using machine learning to be able to take actions based on some of the calls. Can you talk a bit about how you're leveraging machine learning inside GameSpark today?
Yeah, so what we realized by virtue of getting this huge amount of information about how players interact with the platform is that we've got a really valuable stream of behavioral data.
Yep.
So what we can do by virtue of having this data is analyze that as it's passing through the platform and be able to make really rapid decisions about player behavior. So the principle here is we want to be able to close the loop between insight and action. Yeah. And what we mean by that is if it looks like a player is going to behave in a certain way, so if a player looks like they're going to churn from the game, we want the developer to be able to act on that as quickly as possible.
Sure.
So how they could do that is maybe offering them a different experience, which could be different rewards within the games or different level of difficulties, or giving them free things, or anything to encourage the player to stay in, market to them in a different way, etc. If we can make that decision really quickly based on seeing their behavior in real time, there's a much higher chance of that player being retained in the game than if we go and make an offline decision maybe a day later. The traditional approach of shipping your data off to a third party and then them responding a day later saying these are the players who are likely to churn isn't good enough in this world. A day later is probably too late. We want to be able to make that decision in real time.
What does that experience look like? I know you're working on it, but what does that experience potentially look like? Is this like a configuration parameter? What do you envision that experience look like?
Yeah, so in terms of identifying churn, one of the techniques that we're going to use is identifying what disengagement is. So looking at the profile of how players play the game, when they play it, how often they play it, how long they play for, kind of things that they do within games. And if the pattern of that behavior starts to change, then that's an indication that something's maybe not so good.
Sure. And is that like some number that's measured, and then I can write scripts based on this number to be able to react? What does that look like?
Our intention here, our nirvana, is to be able to get to what we call auto-tuning.
Okay.
One of the fundamental features within the platform is segmentation. So developers can actually already segment their players based on certain attributes of players, or they can explicitly put a player in a segment. What we will do as part of our next generation of analytics is to be able to, when we identify players exhibiting these traits of maybe likelihood to churn, or at the other end of the spectrum, likelihood to monetize, or some other positive indicator, then we'll automatically put these players into segments. And then the developer will be able to choose what experience they present to those segments. So it could be all of the features in the platform are naturally segmentable as well. So if you're creating a virtual good, you can say the price of it is 50 gold coins to one segment, is 100 gold coins to another, and whatever. So as a player moves to a different segment, they automatically get a different economy experience, for example. Or it may be that different difficulty parameters are applied to people in different segments.
Wow. You mentioned earlier that when we were talking a bit about different cloud provider, or I think you were talking about locality, we were talking about moving into the Chinese market. What was that experience like, moving into, I guess, not being in the Chinese market now all of a sudden? I'm assuming that the behavior that drove that was the firewall in China being able to get access to data. Is that correct?
Absolutely. So the initial driver for getting deployed into mainland China were actually Western customers who were saying to us that they needed to be able to run games for Chinese players, and the Great Firewall being the obvious inhibitor.
Yeah.
So we decided we'd go and deploy one of our runtime clusters in mainland China to meet that demand.
I see.
It's certainly an interesting journey to be able to get us to do that. In terms of functionality, so as you know, we use the AWS Beijing region as our deployment location there. And anybody who's looked at AWS in China will probably see just on the face of it that not all of the AWS services are available in that location. It's only a subset of them.
Okay. That's
generally not a problem for us because pretty much all the services we need are there. But there's some interesting things, like from a security perspective, there's no multi-factor authentication for AWS users, and there's no EBS disk encryption natively in China. So that's interesting compared to the other locations. The other major thing that we came across and that we didn't know before we started deploying there is that to have any services that are available on the public internet in China, you need a government certificate called an ICP license, which you need to apply for, explaining what your type of business is, and the government decide whether you'll be allowed to have your services on the internet. The interesting thing about the ICP license is it also includes explicitly the IP addresses you're allowed to use. So in an environment like ours, where we dynamically scale and ordinarily cycle through IPs relatively quickly, that becomes a bit of a complication.
Yeah.
So in this case, we simply over-provision the number of elastic IPs that we have, and then make sure we never give them up, because there's a lot of government hoops to jump through if we want to have more IPs onto that list.
Wow, we've been talking for a while, Greg. I think I could keep going and asking questions for another half hour or so, but I better wrap up. So we've been talking to Greg Murphy, the COO of Gamesparks. If you want to hear more about how they package and deploy their services across all three major cloud providers or any of the topics you just heard, Be sure to look for Greg's video from QCon London 2017. It should be posted in just a few weeks to come. Greg, thank you so much for joining us.
No problem. Very much enjoyed it.